Right guys, what we're looking at today is 3D Pythagoras, which is basically using Pythagoras in a 3D environment. All right, I'm gonna have to do it 2D on this bit of paper. I've got a lasagna box to show you what I mean in terms of the 3D, okay? So this is obviously a 3D shape, it's a cuboid, okay? What we're actually looking for is what's called the space diagonal, okay? So what I want to find is the length from one corner through the middle of the cuboid to the directly opposite corner. So from this corner up to this back corner here. It'd be the same length if I went from this corner down to this corner here, and likewise from this corner to this one over here. Okay, it would all be the same length, but it's what's called the space diagonal. Okay, so what I've done is I've taken my lasagna box and I've drawn it here. Okay, so I'm using my kettle again. All right, so this is this lasagna box. Okay, so you got the height of it. Okay, is 12 centimeters. The width of it is 3 centimeters, and then we've got the other dimension is 4 centimeters. So what we're trying to find is we're trying to find the length of that pink line there. So straight through the middle of the 3D shape. All right, so I've represented this triangle here. So what you notice is that this is a triangle. And more specifically, if I draw this line in here, it's a right angled triangle. So it's very hard, I know, to picture this because this is a 2D version of a 3D shape. Okay, but just as best as you can, try and imagine that what we've got here is a right angled triangle, okay? So that's over here. So we've got EA down this left-hand side, okay? Across the bottom, we've got this diagonal, which goes across the bottom face, AC, and then the pink line is what we want to find, okay? Now, in terms of the lengths that we've got, if you notice, obviously, if this is 12 centimeters, then all of these different heights are 12 centimeters, just like with the lasagna box, okay? So if the height of one side is 12 centimeters, then all the way around, okay, it'll be 12 centimeters, all right? So in that case, this side here must be 12 centimeters, okay? But the problem is at the moment we don't know the length of this blue line, okay? But what again we have is we have another right angle triangle. So if I just sketch this one out for you here, okay? You can't see this one, okay? So it's this bottom one here. So we've got the blue dotted line is our hypotenuse this time, but this is on the bottom face of our 3D shape. And we know that this length would be 3 centimeters and this length would be 4 centimeters. So in order to find this pink length, we need to have known this blue length already. Okay, and we can use that bottom triangle to find that blue length. Basically what we're doing is Pythagoras twice, but we're doing it obviously in a 3D environment. This is doing it in a context, okay? So I'm going to start by finding this blue length here. So again, just remind yourselves of Pythagoras. This is going to be our C, in which case we've got an A and a B. And we know from Pythagoras that c squared will equal a squared plus b squared, okay? So remember, none of these really look like right angles, okay? But because obviously it's a 3D shape, they are actually right angles. It's a cuboid, we know that from the question. So we're gonna do 3 squared plus 4 squared, which is 9 plus 16, which is 25. And therefore c is gonna be the square root of 25, which is 5. Okay, that's centimeters. Right, so now we can take that length, so that 5 centimeters, and we can say, right, if that 5 centimeters is that length there, okay, then this must also be 5 centimeters. So now we have all the dimensions that we need to be able to find the pink side. So again, we're just doing the same thing, and again, you'll notice that this is just another c. It's the longest side, it's a right angle triangle, so it's going to be c squared equals a squared plus b squared again. We're using different lengths because it's a different triangle this time. We can label this one my A, this one my B, in which case it's 5 squared plus 12 squared, which is 25 plus 144, which is 169, okay? Therefore, if we want to find C, it's the square root of that, which is 13 centimeters, okay? And that's how you find the space diagonal in a 3D shape using Pythagoras. Okay? So this length here is just 13 centimeters.